So I said by substituting 2, I obviously would not get 0, but we still have to show it, right? So 2 cubed, that's 8. 8 times 2 is 16. 2 squared is 4. 4 times 7 is 28. And then this is plus 6. This will give me 34. 34 plus 16, that's 60. No, 50. Let me just double check this. Mental maths. 3 plus 6 plus 16. 50. Okay, nice. So that's obviously not 0. So what does that mean? This is also not a factor. I know this is tedious, but this is what you have to do. You have to show all of this to get your marks, right? Then we try minus 2. Is minus 2 going to work? That's what we need to find out. So I substitute minus 2, minus 2, minus 2. Would this give me 0? Remember, if I get 0, meaning that if my remainder is 0, that means that this would be a factor, right? That's our whole aim. We're trying to find a factor. Which number, when I substitute it into this polynomial expression, which number would give me 0, a remainder of 0? That's my goal. So minus 2 cubed, minus 8. Minus 8 times 2, that's minus 16. Minus 2 squared, that's 4. Minus 6. So what is this going to give me? This is minus 32 plus 28, which is let me make sure, minus 32 plus 20. Yep. This does not give me 0. What does that mean? This is also not a factor. So yeah, they were kind of wicked this year because you have to go through all this, but that's fine. Usually when you're doing this whole trial and error thing, usually you'll get a factor after substituting like minus 1 or maybe 2. By that time you will get a factor, but in this case, no. We have to continue. So now I substitute 3 into this polynomial expression. Would 3 give me a value of 0? Well, obviously not, but you still have to show it. Substituting 3 into here. That's 27. 27 times 2 is 54. 9, 63 plus 9. Oops, plus 9. So that's 126. That's 126. Let me just double check that. Yes, 126. That's obviously not 0. What does that mean? This is not a factor. So usually it doesn't take you this long to find it. Like I said, you would get a factor around, when substituting minus 1 or maybe like 2. But this question is just headache. So since 3 didn't work, we need to substitute minus 3. Would minus 3 work? Well, let's see. Minus 3 cubed, that's minus 27, minus 27 times 2, that's minus 54. Minus 3 cubed, minus 3 squared is 9. 9 plus 7 is 63. And then 3 times minus 3, that's minus 9. This is going to give me 0. Why? Minus 54 minus 9, that's minus 63, and minus 63 plus 63 is 0. So what does that mean for me? Well, since when x is equal to minus 3, my remainder is 0, that means that my factor is x plus 3. And this is the factor I would be using for my long division. Everybody good so far?
Wait, yeah, I'm
You sounded unsure. If you're not good, let me know. So can I clear this?
wait, I'm going right now.
Okay.
I'm finished.
Okay, if anybody needs to stop me, let me know now. 3, 2, 1, clear. So now that we have our factor after all of that, yes, you have to write all of that. So just make sure you write all of that, right? Now that we have a factor, we can do our long division to find the other linear factors. So this is my polynomial expression, plus 7x squared plus 3x. And we now know that our factor is x plus 3. So are we doing? We doing long division like we were doing before. X into 2x cubed, that's 2x squared, 2x squared, 2x. Anyways, 2x squared multiplied by x, that's 2x cubed, 2x squared multiplied by 3, that's 6x squared. You always subtract them. This will give me 0. 7x squared minus 6x squared will give me x squared. You bring down the next two. Plus 3x. X into x squared, that's plus x. X multiplied by x, that's x squared. X multiplied by 3, that's plus 3 squared. Plus 3x. Well, minus x squared minus x squared is 0. 3x minus 3x is 0. No need for me to continue because the constant term is 0, right? So no need for you to do that. What does that mean? That means that this right here is a factor. This is also a factor. Oh. Okay, just pretend that's circle, right? So this and this, they're both factors. So what I would say, the factors of this polynomial expression, x plus 3 and 2x squared plus x. However, you don't leave it like this. Why? Because you can't factorize this. You must completely factorize. Okay? So since this can't factorize, I must factorize it. So when I factorize this, what am I going to get? Okay, let me clear this and do it as a full screen. So just let me know when you finish with this so I can erase it.
Yeah, finished.
Okay. I hope everybody else finished. If you're not finished, let me know. Okay. Yeah. Anyways. So everything is clear. What are my factors? My factors are plus 3, 2x squared. Wait, hold on. Okay, right. So 2x. Checking to see if this could factorize. Theta the x. And I'll end up with this. So what does that mean for me? Well, my final answer, since they asked me, for all of the linear factors, x plus 3 is a factor, x is a factor, and 2x plus 1 is a factor. These are my 3 factors of this polynomial. So that is what you would write. So, everybody good?
Yes, miss.
Okay. What was the other part of the question? So this one, they asked for all the linear factors. Those were your 3 factors. How many marks? 3 marks. Then the second part, they wanted you to compute the roots of the function f of x. This is nothing new. When they want you to find the roots, what that really means is to solve the polynomial, right? Just like quadratics, when we factorize, we would find the factors. We would find the two factors. And then when we wanted to solve or find the roots, we put each factor equal to 0. Okay, hold on. I can still talk. So just like when we were solving by factorization, when we're doing quadratics, to find the roots, we put each factor equal to 0 and we solve for x. Same thing you're doing here. When they ask you for the roots, all you do, put each factor equal to 0, find your values of x. So that's exactly what we're doing now. All the PowerPoints except this one right here are already on Google Classroom. Like all of them, except this one. This one I'll post it tonight because I'm now finishing the topic. But the rest of them already on Google Classroom. So compute the roots. We find the roots. How do you find the roots? You solve. How do you solve? Put each factor equal to 0. Solve for x. That's all we do it. Okay? Nothing difficult, nothing new. We did this when we were doing quadratics. So what are my factors? Well, we just found out that the factors of this polynomial are x plus 3, x, and 2x plus 1. They want me to find the roots. All I have to do, put each one of these equal to 0, solve for my value of x. So my first factor, x plus 3. I put x plus 3 equal to 0, I solve for x. So what's my value of x? X is equal to minus 3. Next factor, x is equal to 0. You don't have to do anything there. X is equal to 0. Next factor, 2x plus 1, put that equal to 0, solve for your value of x. What does that mean? X is equal to minus a half. But they ask you to find the roots. So you should write your answer in this form. Minus 3, 0, 0, 0, and minus a half, 0. We know that the roots of a graph means wherever the graph cuts the x-axis. The graph would cut the x-axis at these 3 points. And that's the answer. Everybody good with that? Yes, no? If you need me to explain it again, let me know.
Can I explain it one more thing?
Which part? The whole thing?
Yeah.
Okay. Last part. So there are two parts of this question. The first part, they asked me to find all the linear factors. We found out that these are the linear factors. You understood that part?
Yeah. I understand the blue part. No, I understand. Wait. I was doing something that way. Wait, I understand.
Okay. Just in
Sorry.
case anybody, don't apologize. It's fine. Just in case anybody else did not understand and doesn't want to speak up, they asked me to find the roots. Just like when we're doing quadratics, if I told you to solve by factorization to find the roots of the quadratic, what you would do, you would put the factors equal to 0 and solve for the values of x. Same thing you're doing here. I have my factors, I set each one equal to 0, I find my values of x. But I was telling you, don't just leave your answer as x is equal to whatever. They ask for the roots. So write it in coordinate form, right? So we know that the roots are wherever the graph cuts the x-axis. So my roots of this polynomial expression, or the function f of x, that's the function that they gave us, would be minus 3, 0, 0, 0, and minus a half, 0. Okay, so just in case anybody didn't know and want to speak up, you know now, right? So let me just show you what this might look like. You don't need to learn this, right? This is just me showing you something extra. So the roots of this polynomial. This was the function f of x. The function f of x was given as 2x cubed plus 7x squared plus 3x. So what this graph might look like, I have my oh my gosh, line, that line was so crooked. Oh my, this is not working out. But anyways, let's pretend that's a straight line. That's my y-axis. Let's pretend it's a straight line. That's my x-axis. What this graph might look like, they told me that the point, well, we just found out that the roots, -3, 0, so I have my -3 here. This is 0, 0, the origin, we know that. And then -0.5, 0. So let's just say -0.5 is here, right? So what this graph might look like, because it's a polynomial to the third degree, remember you don't need to learn this, right? This is just me showing something extra. This might look like
Amount. Oh, I thought it was a minimum.
What?
I thought it was a minimum curve.
Yeah, that's why I started off like this.
Oh yeah.
Instead of like this. So this, that's how it looks like this. Anyways, you don't need to learn that. That was just me showing you something extra. If you confused, don't worry about it. So we finished all the past paper questions for polynomials. Yay! That's it for polynomials. We did everything. We did all the past paper questions in existence for CSEC. So congrats.
But I'm not going to remember everything. I'm going to practice it. I'm going to practice it.
Yes, practice. Practice makes perfect.
Yeah.
Yeah, we did all this already. We did all the past papers already. So yay. Okay, so what we're doing for the rest of the class now that we finished polynomials, wait, before I continue, anybody has any questions about this topic? Going once, going twice. Okay, so PowerPoint, I would post it on Google Classroom tonight, so you would have it. These are the main things you have to know. When I say to know, I mean like what you need to quote unquote memorize, but it's not really memorizing if you understand, right? But yeah, these are the main things you have to know for this topic. I'll post this on Google Classroom. So what are we doing now? Well, we are going to review logs. Logs and indices. Well, yeah. And after we do that, like after I go through this PowerPoint real quick, we're going to do a little quiz, just to refresh your memory on that topic. That topic was done so long ago, like 3 weeks ago, 2 weeks ago. I hope you didn't forget, but let's see now, right? Logs, the log of a number. Oh gosh, hold on. So we said that the log of a number to a given base tells us the power to which the base must be raised to get the number right. So if I have log of 8 to the base 2 is equal to 3 in English, without all the math symbols, that means I need to raise 2 by the power of 3 to get 8, right? So that's what finding the log of a number means. We did all that already. We did all these. Remember the laws of logarithms that you need to know. Just like for surds and indices, how you have laws, for logs, you have laws that you need to know. You must know. We did examples. We did solving log equations. We said to solve log equations, one of the two following rules apply. So this first one, if you're given an equation in log form, for example, this, if this was a question, right? They told you to solve log of 16 to the base 2 is equal to x. That's log form. We learned that, right? If you're given log form, then we know that log form can be written into exponential form. The log form and the exponential form are related, right? If this is my log form, log of x to the base a is equal to n, then exponential form is a to the power of n is equal to x. So that's the first way you solve log equations. But not always would you get the equation in log form. What if you get it like this? Logs on two sides. That's not log form. Why? Log form has a log on one side and then a number on the other side. This question here has log on both sides. That's how I would know I can't use the first rule to solve this, right? You already did that. So because this isn't in log form, what other way can I solve this equation? Well, we also know a rule that says log of n to the base a is equal to log of m to the base a. If I'm given this, then n is equal to m. Log of x divided by 2 to the base 2 is equal to log of 2 to the base 2. Because I'm given that, I can then say, according to my rule, that x on 2 is equal to 2. And wait, why didn't I change that? I would change that. This is supposed to be 4. Anyways, I'll change that. So the value of x is 4. We already did that. We did this. We did this. This was a note. When solving, we learned when we were doing exponentials or indices that when solving these equations, exponential equations, I mean, we have to write both sides to the same base and then we can equate the powers. However, if there's a case where you just cannot write the both of them to the same base, what do? Well, we apply the rule log of n to the base a is equal to log of m to the base a, then n is equal to m. What do I mean by that? Well, we take logs on both sides and then we can apply this rule. So say we're given 2 to the power of x is equal to 5. We just cannot write these two to the same base. What do? When this happens, well, I take log on both sides. So this becomes log of 2 to the power of x is equal to log of 5. You know, applying your log rules. So we already did this, right? This is a rule that I would apply here, right? So log of 2 to the power of x becomes x log of 2 is equal to log of 5. Then I can say, okay, x is log of 5 divided by log of 2. Remember, for this exam, whenever you see log without a base, you assume that the base is base 10, right? Anytime you see log by itself, so log without a base, you assume that the base is base 10. So we did all that. This is log graphs. Log graphs. Okay. And that's what you have to know. Okay. Now that we did not recap, any questions? If I was going fast, that's because we did this already, right? If you have any questions, let me know. But let's do this quiz now. Hold on. Let's do. So click on the link.